So I am assuming this building is an office, and this office has got resources in it. So there are a set of persons who want to use the resources. And this security guard, I am considering him as a semaphore. And the task of this semaphore is, it will allow only one person entry in the office. So let us see how it happens. Now what the users who want to use the resources have to do is, they have to use the wait and signal operations of the semaphore. And as you know that semaphore variable s is equal to 1 if the resource is free. Semaphore variable s is equal to 0 when the resource is busy. So what happens here is, if this person, for example, wants to use the resource in the office, he cannot immediately enter the office and start using the resource. What he has to do is, he has to use wait and signal operation to use the resource. Let us say, for example, this 6 people want to use the same resource. Now the condition is that they can use the same resource provided only one user is using the resource at a time. When one user is using the resource at a time, the other user should be kept in waiting. So that's what is the purpose of mutual exclusion. So only one user can use the resource at a time, or only one process can use the resource at a time. Now let me say this security guard here is a semaphore, and anybody who wants to use the resource uses the wait and signal operations of the semaphore. So the security guard will give permission to only one person to enter the office, and after using the resources, this person can exit. So when this person is using the office, the other persons are in the waiting state. So they are waiting. And this person is using the resource. So when this person is using the resource, at that time, the semaphore variable will be equal to 0. After this person finishes working with the resource, it will leave the office. And when it leaves the office, after using the resource, it will set the value of semaphore variable to 1. In that case, what happens? The security guard will, after this person leaves, will allow the other person to enter the office. So let us say how it happens. So this person has finished. Now the turn of the next person comes. So semaphore is set to 0, and this person enters the office. So like this, what happens is, whenever we are using semaphore will guarantee that only one process out of a set of process will use the resource, the other will be restricted from using it. It guarantees mutual exclusion. But imagine that this person is given the resource, access to the office, and this person, what he does is, let us say, what is this? This is not working. So this person is given access to the office. He goes inside the office. Semaphore value is 0. and we don't know what this person will be doing when the person is given the access to the office. So what I mean to say is that this person entering the office may do something wrong with the resource, may try to damage the resource. So the security guard will not have control on him. The purpose of the security guard here is to allow only one person to enter the office. And what this person does after going into the office, whether he is using the resource in a proper manner or not, in an ethical manner or not, or whether he is damaging the resource, this person will not be able to guarantee. That is, semaphore will not be able to guarantee. They will only allow only one process to use the resource at a time. The other process will be kept out. They will not be allowed to use the resource. That is what is the basic purpose of the semaphore. So in other words, what I mean to say, semaphore will not provide any kind of security to the resource. Now we want two things to happen. One is we want a process to use the resource exclusively. Means exclusive means what? Only one process using the resource. We also want that the resource should be protected. So protection will not be provided by semaphore. Semaphore will provide only direct access to the resource. So direct access to the resource is not a wise solution, or it is not advisable, because direct access to resource may lead to ethical operations, or sometimes it may lead to unethical operation. See, by mistake also a user may try to damage the resource, or by evil intentions also a user may try to damage the resource. So what we don't want only a process to be allowed to use the resource exclusively. We also want that whichever process is using the resource should use the resource with responsibility. That is, the resource should not be damaged by the process. So that's what basically we want to deal with. So what I can say is that semaphore is only meant for mutual exclusion. It will allow exclusive access to one process, or you can say exclusively it allows one process to directly access the resource. So I just note down, semaphore will allow exclusive access to a process to use the resource directly. The resource may be used for writing or reading or manipulating the data, whatever it might be. So here, since direct access is given by the semaphore, that's why we have a problem. And to avoid that, we are using another extended mechanism that provides not only mutual exclusion, but also provides access to the resource by protecting the consistency of the resource. So let us see another example here. So in this example, you can see that again there is a security guard here, and this is the office, and inside the office there might be files to be read or to be written, and there are 3 visitors or 3 persons who are waiting to use the resource in the office. Now this time what happens is, when any of the user wants to use the resource, he will approach the security guard. The security guard will not allow this person inside the office. Instead, what the security guard will do is, he will ask what is the work he has. Now let us say this person says, I want to perform a write operation. Then the security guard will say that whatever is to be written, and now let us not make it very complicated. Let us say there is a buffer. There is a buffer of size 0 to n-1. Now this is a person, I'll name him as a producer. Means he has produced some information and you want to put that information in this buffer. What semaphore will do is, it will allow the producer to directly use the buffer. But here we don't want to do that. We do not want any producer to directly use the buffer or directly perform operation on the buffer, or we don't want any consumer to directly access the buffer for removing the information from the buffer. So what is happening here? We are not allowing the producer to directly use the buffer. Instead, what we are doing, we are asking the producer to meet the security guard and tell him that he is the producer and he wants to insert some information in the buffer. Whatever information the producer wants to insert, he will give that information to the security guard. And the security guard will go to the office and he will put the information in the buffer. So what is happening is the information is not directly inserted by the producer in the buffer. The producer is unable to insert the information in the buffer. Rather, the producer is giving the information to the security guard, and the security guard in turn is putting the information in the buffer. So this security guard is a trusted person. So he will not do any harm to the resource. He is so trusted that if you ask him to only perform write operation on the buffer, it will perform the write operation. Similarly, there is a consumer. Now, consumer, what is the purpose of a consumer? The purpose of a consumer is to only remove the information from the buffer and use it. So again, we are using a mechanism. Again, the security guard is a person here, which is not allowing the person to enter into the office. Rather, it will ask, what do you want? So this person says, I'm a consumer now. So what the security guard says, that you cannot access the buffer directly. I will get the information for you and you can take the information from me. So the security guard will access the buffer because he is a trusted person. So he will remove the information from the buffer, that is A, and it will hand over it to the consumer. So what is happening? This person, that is a security guard here, is allowing only one person to, deal with this buffer. The other should be in waiting, like semaphores. But the difference between semaphores and monitors is that in semaphores, the person can directly perform operations on the buffer. Only one person can perform operation directly on the buffer. But here, I'm using another mechanism where the person cannot use the resource directly. Instead, the person has to approach a in-between mechanism, a mediator, and he should tell the mediator that I am producer and I want to insert the information in the buffer. So that person, that mediator, will take care of inserting the information in the buffer of that producer. So what the mediator will do is, it will take the information from the producer. Let us say he is the producer, and after taking the information from the producer, the security guard will put the information in the buffer. Now suppose this person has finished his task, then he will give turn to the other person, and second person is now say consumer. Then third person will be in the waiting state. This person will be in the waiting state. Now this person is say consumer. So what this consumer will do? It will request the security guard. It will request the security guard to remove the information from the buffer and give. The security guard will remove the information from the buffer and it will hand over the information to the consumer. So this way, this mechanism is performing two things. One is exclusive access. Only one person can access the buffer, but the access to the buffer is not direct, it is indirect. So direct was given by the semaphore. So now no direct, only one person or one process can use the buffer, but it cannot use it directly. It has to use it indirectly through the security guard. This security guard is what is I called monitor. So the difference between semaphores and monitors is that semaphore will give exclusive and direct access to the resource, whereas monitors will give indirect and exclusive access to the resource. So this is what you need to remember: indirect and exclusive access. It will maintain mutual exclusion, but it will allow the users to access the resource indirectly. Now, this is what is called data protection, or you can also call that monitor supports data abstraction. I think you might be familiar with uh, Java. In Java, you have something called encapsulation, where encapsulation means hiding the data and the functions that act on it together, or it means enclosing the, not hiding. Encapsulation means enclosing the data and the functions that act on the data together. That is what is the meaning of encapsulation. So here it is data abstraction. Data abstraction means, I'll just explain you. So what monitor does is, this is the monitor. Now the buffer that is used by the producer and consumer will be belonging to monitor. Let us say monitor is a program that implements mutual exclusion and allows indirect access to the data. So the buffer is now belonging to the monitor. So this buffer is, let us say, data structure that is declared as private. So in Java, you have seen that whenever you declare the method or data as private, it can be accessed within the class. So data structure is private to the monitor. It cannot be accessed outside the monitor. So any process Px or Py cannot directly put the information in the buffer or remove the information from the buffer. These two operations are not allowed, because outside processes cannot access the private data of a process called monitor. In Java, if you declare in a class, this buffer is a private data structure. Within that class only, you can access the buffer. Any object of a class outside the monitor class cannot access the data. So by that concept of the buffer belonging to the monitor, we can see that the outside processes will never know whether the buffer implemented by the monitor is an array or it is a structure or it's a linked list. They will not be knowing about the the structure of the buffer. So data abstraction or abstraction basically means that the essential details are only known to the user, the unessential details are not known. So for example, if this monitor is holding the buffer which is private so that it cannot be accessed by outside resources, it declared as private. Process X and process Y will never know how this data structure is implemented, whether this data structure is a linked list or it is a structure or it is array, whatever it might be. The implementation details of this buffer will not be known to process X and process Y because it is abstracted from the outside process. Now let us say this process is called the producer process. So if suppose we are not allowing the producer or consumer to access the buffer, then how should the producer put the information in the buffer and how should the consumer get the information from the buffer? See, what happens here is, since this buffer is private to the monitor and the monitor will not allow the producer X to directly put the information in the buffer or the consumer to remove the information from the buffer directly because the buffer is private and cannot be used by outside process. What the monitor does is it will have two functions or two methods. One is called put, the other is called get. Now these two methods are public. They are declared as public. So please understand, The data here is declared as private, cannot be accessed by outside process. But there are two functions, put and get, that are public. They are declared as public. Public means these two methods can be accessed by outside process. So what is happening here? We are saying that the producer cannot directly put the information in the buffer. So why the producer should be interested in knowing the structure of the buffer, whether the buffer is array or structure? What is the main intention of the producer? Producer wants to produce the information and put the information in the buffer. That's what is the intention of the producer. So the producer should not be curious to know what is the content, or what is the, how the buffer is implemented, whether the buffer is array, or whether the buffer is structure, or whether the buffer is linked list, whatever it meant. The producer should not be curious to know, or the producer need not know how the buffer is implemented. The producer should only see that whatever information is produced by it, that information should be put into the buffer. So what the producer does in this case, the buffer structure is not known to the producer. Only the producer has visibility of put function. The producer only knows that there is a put function in the monitor. So whenever the producer wants to put the information in the buffer, it will invoke the function called put. And to this put function, it will supply the data. So what the monitor does is, on behalf of the producer, it will put this information in the buffer. That means to say, producer cannot directly put the information in the buffer. Instead, what the producer is doing, through the method, through the function provided by the monitor, which is of type public, it is supplying the data, and the data will be put by the monitor into the buffer. Similarly, if the consumer wants to access data from the buffer, the consumer cannot access it directly, as I told you earlier. So if the consumer wants to access the data through the buffer, then how should it access it? First of all, consumer need not know whether the buffer is a structure or linked list or whatever it might be. The consumer is only to be interested in accessing the information from the buffer. So what the consumer will do, it will not be able to access the buffer directly, but indirectly it can access the buffer by invoking a function called get. Because get is a public function, it can be accessed outside. Now what this get function will do, it will remove the information from the buffer and it will give to the consumer. So if there are multiple producers, producer Y, producer Z, consumer, we have say consumer X, consumer Y. So the monitor will only allow one particular process to invoke the function put. When producer X is invoking the function put, producer Y cannot invoke the function. That is where mutual exclusion is used. Another thing is that the producer cannot access the buffer directly. It has to put the information in the buffer only through the function called put. So two things are happening here. What are the two things? Two things are allowing producer or consumer to access the buffer. That buffer is inside the monitor. So I think some more people are trying to get inside. Okay. So here there are two functions, put and get. These are public. This data structure is declared as private. That is the buffer. So producer will put the information through this function called put, and consumer will get the information through the function called get. So get will get the information and gives it to the consumer. So it will allow only producer X to access the function. It will not allow producer Y or producer Z to invoke the function put X. So producer Y will be waiting and producer Z also will be waiting. only one producer can invoke the function put. Similarly, if consumer X is invoking the function get, consumer Y and consumer Z should be waiting. Consumer Y will wait and consumer Z will wait. So this is what is the monitor. So let us see one example of monitor program. See, this is a typical structure of a monitor program. Now you may see here how the monitors are implemented. A monitor will have a name. A monitor will have a name. So some students are logging in and logging out. I don't know why. What is the problem? So anyway, let us come to the topic here. A monitor will have a name. So this is the name of the monitor. Monitor will have declaration of data. But as I told you, the data is private to the monitor. It cannot be used outside. Now a monitor will have procedures or functions, and these procedures may be public procedures, and it will also have procedures which are private. So procedure basically means a method. Procedure basically means method or function. So don't get confused. So here, this procedure here means function, or in Java we call methods. So there is a function which is of type public, which means that it can be accessed by outside users also. And there is a function. This is declared as private, cannot be used outside the class or outside the monitor. Cannot be used outside the monitor. So please remember that a monitor is a program. That program consists of a set of procedures, data. Data is private to the monitor, and procedures may be of two types: public procedures and private procedures. Public procedures means they can be accessed by outside process. So this public procedure or public function can be used by outside process, whereas this is a private procedure. Private procedure cannot be used by outside process. It is for the purpose of monitor itself. Means within the monitor only the private procedures can be executed, and data will be manipulated by the monitor internally. It will not allow the data to be manipulated by outside functions. So initialization of the data also is done by the monitor. So in a nutshell, a monitor is a program that has a set of data which is private to the monitor. It has a set of functions or methods. Some methods will be private, some methods will be public. Private methods cannot be used by outside process. It's like Java. In a typical Java class, if you declare the variables and the functions as private, those variables and functions can be used within the class. Any other class cannot access those private functions and private methods or private variable of that class. If a class is declared its variable as public and methods as public, then outside classes or outside process can access those public methods and public variables. It is same like a typical Java program, where in a Java class we can declare public methods and private methods, public functions and private functions, and data as private or public. Public data and public functions can be accessed by outside process, but private data and private functions cannot be accessed by outside process. That is the meaning of public and private here. So here, as I took an example of producer consumer, you have seen that the monitor will be holding the entire data with it, and it cannot be accessed by outside process because it's private. Any person who wants to use this data, like process X is there or process Y is there, if they want to use the data, they have to use the public procedure. They have to invoke the public procedure. This public procedure will perform the operations on the data, and the results will be given to the process X. Process Y is trying to access the private procedure, it will not be allowed. If process X wants to access this private procedure or private function, it will not be allowed. If producer X wants to, or process X wants to use the data directly, it will not be allowed. That is the meaning of the monitor. Now we'll take an example of how these monitors can be used for implementing a semaphore. So see, anything that can be done by semaphores can also be done by monitors. So here what I want to show you is, I want to show that if semaphore can provide mutual exclusion, even monitor can provide mutual exclusion. So what operation is done by semaphore, the same can be performed by the monitor. That is the meaning of it. So let us take an example where by using the concept of monitors, we'll implement a semaphore. So I'm very clear. Monitors can be used to implement semaphores. Let me take another example. So if you want to get some more clarity, you can see the slide here. I have mentioned in the bottom note that monitors go a significant step beyond semaphores. So monitors go a significant step beyond semaphores. In what way? By making the critical data accessible indirectly and exclusively via a set of publicly available procedures. So that's what the meaning of it. I don't know whether you are able to see this slide. I have mentioned here. You can note down if you want. Monitors go a significant step beyond semaphores by making the critical data accessible indirectly, not directly. Please concentrate on this word, indirectly, because in semaphores it is directly. It is directly and exclusively, but in monitors it is indirectly. So next slide will go. I said we'll implement the semaphores by using monitors. Now see here in this slide, there is a program or there is an algorithm. Let us try to understand this algorithm. So this algorithm, what it says, sorry. Please see this algorithm carefully. This algorithm is algorithm used for implementing semaphores. You see that, as I earlier said, a monitor will have a name. So the name of the monitor is, say, wait and signal. Now in this monitor, you have two procedures. One is called mwait, the other is called msignal. These are the two names. Procedure mwait, procedure msignal. I want to make this two function behave as wait and signal functions of semaphores. So in that way, if suppose any process, say process 1 and process 2, both have critical sections. Mutual exclusion says that when P1 is in the critical section, P2 should not be in the critical section, or when P2 is in the critical section, P1 should not be in the critical section. So we have seen in semaphores that entry into the critical section is given by the semaphore by using two operations, wait and signal. So if process 1 wants to enter in the critical section, it has to execute wait. If after coming out of the critical section, it has to execute signal. So initially s is equal to 1. If P1 executes wait of s becomes 0, and P1 will be in the critical section. If at that time P2 wants to enter, it cannot enter because s value is 0. So it will be looping here. It will not be entering the critical section. After P1 comes out of the critical section, it will execute signal of s becomes equals to 1. As soon as s becomes equals to 1, P2 will set the value of s to 0 and it will enter the critical section. So as long as P2 is in the critical section, the value of semaphore will be 0 and it will not allow process 1 to again re-enter into the critical section. This is what we have seen in the semaphores. Now we'll see by using this monitor. Again, please remember, this monitor is a program. This monitor is a program. Process X and process Y are processes which are outside the monitor. So you can say this is process Z. Monitor is process Z. Process X is a different process. Process Y is a different process. Now process X has a critical section. Process Y also has a critical section. To implement this mutual exclusion by using the monitor, let us see how it does. Let us say procedure mwait is public function and procedure msignal is a public function. Now what what process X and process Y has to do is, if process X has to enter the critical section, it has to invoke a function called mwait in the monitor. Because it's public, it can be accessed by outside process. Similarly, if PY wants to use the critical section, it has to invoke the function called mwait belonging to the monitor. After the process X comes out of the critical section, it should invoke the function called msignal, which is a public function again belonging to the monitor. So again here, msignal is invoked by process Y that belongs to the monitor. So the critical section of PX is enclosed by mwait and msignal. Critical section of PY is enclosed by mwait and msignal. Here we are declaring one variable called busy as Boolean. Now please understand one thing. Monitors has borrowed the concept of wait and signal from the semaphores. Monitor has borrowed the concept of wait and signal from the semaphores. The common thing between monitor and semaphores is that both of them has wait and signal operations. But the difference between monitor and semaphore is that there is something called a condition which is used by the monitor that you are not found in the semaphores. I'll just let you know what is the meaning of this condition. You can assume this condition as the header of a queue. You can assume this condition as a header of a queue. So say there is a queue here, and this header of the queue is called a condition, and the name of this condition we have given as free. So free is the name of the condition. So please remember one thing, the difference between the common thing between semaphores and monitor is that both support wait and signal operation, or rather you can say that monitors has borrowed the concept of wait and signal from semaphores, but the unique thing in monitors is that it has something called a condition. This condition is a queue, or this condition is a header of a queue, as I have written here. So condition is nothing but header of a queue. Name of that header of the queue is free here. So when I say free dot condition, you should understand that free is the name of the header of the queue. Free is the name of the header of the queue. So these variables and these conditions are private to the monitor. It cannot be accessed by outsiders. And these variables can be initialized only by the monitor. So busy is set to false by the monitor only. You cannot set busy to false or true by using outside process. Outside processes cannot set the value of busy to false or busy to true. So initialization of the variables within the monitor is done by the monitor itself. So monitor will initialize the variable. Initializes the variable value busy equals to false. Only monitor can initialize the values. Now let us see how this works. I want to only prove that this particular monitor program will behave like a semaphore. So let us take an example. There is a process X, there is a process Y. Both the process have critical sections. But if process X want to enter, like in semaphores, it should use wait, but now it is using a mWait function of the monitor. If process X comes out of the critical section, it should invoke signal function in the semaphores, but here we are using mSignal public function of monitor. Similarly, PY also has to use mWait public function of monitor, and after coming out of the critical section, should invoke the function mSignal of the monitor. Is somebody waiting now? Okay. So process X, what it does is, it's an outside process, but using the function present in monitor. So process X, before entering the critical section here, it will invoke the function mWait of the monitor. Now what the monitor will do is, it will check what is the value of the busy variable. Busy variable is set to false initially, means the resource is free. Busy equals to false means resource is free. Please remember, busy is a Boolean variable within the monitor, and if busy is set to false, it means resource is free. If busy is equal to true, then resource is in use. Busy is equal to true means resource is not free, it is in use. So that is the meaning of busy variable. So busy can be set equal to false, indicating that resource is free. If busy is set to true by the monitor, it means resource is in use. That's what is the meaning of busy variable. Now, who has first invoked the function mWait? Process X. Process X has invoked the function mWait. So mWait starts executing on behalf of the producer. So I written here, in a way, monitors may be regarded as external function extensions of user process. Something like, when you want to use a math function in your C program, you're including math.h as a header file. So similarly, if you want to use mWait function of a monitor, you are using that mWait function which is belonging to an outside class. Since it's public function, it can be accessed by outside process. So process X has invoked mWait function. Now mWait function starts executing on behalf of the process X. What mWait function will check? It will check whether busy is true or false. So if busy is true, then free.wait. Now please concentrate here. If busy is true, then free.wait. If busy is false, this free.wait will not be executed. Busy is set to true. So busy is set equal to true. Because initially busy is false. So busy is false initially. Process X has invoked the function mWait. So if false, then no need to execute free.wait. If false, the control goes to the next line. Busy is set to true, and the function returns back to the producer X, and the producer X enters the critical section. So busy was false initially. Producer X wanted to enter the critical section. What producer X did? Sorry, no, let us not take producer or consumer here. PX wanted to enter the critical section. And to enter the critical section, px invoked a function mwait, which was in the monitor. Mwait started executing. Busy was initially false, so free.wait will not be executed. The control goes to the next line, that is busy is set to true. After busy is set to true, the control return backs to px, that is process x. As soon as the control return backs to process x will enter the critical section. And the value now set by process x is true. So when process x is in the critical section, let us say at that time process y wants to enter the critical section, what will happen to it? So currently process x is in the critical section. Now py wants to enter the critical section, so py will invoke the function mbait. Now mbait will start executing on behalf of process y now. So it will check whether busy is true or false. Busy is true. Busy is true means it will execute free.wait. Now as I told earlier, free is what? Free is the header of the queue. So this is the queue, and this header of the queue is called free. So busy is true because process x is in the critical section. So if busy is true, then free.wait will be executed. Now let us see what is the meaning of free.wait. It means that if resource is busy, then process y should wait in the header of the queue called free. I repeat once again. If resource is busy, then process y should wait in the header of the queue, and the header of the queue is called free. So process y will be suspended in the header of the queue. Process y will not be executing. How long it will be suspended? As long as process x is in the critical section. So that's the meaning of it. Free.wait means if process y has invoked the function mwait, and if the resource is busy is equal to true, then free.wait means make the process y wait in the header of the queue called free. Make the process y wait in the header of the queue called free. So as long as px is in the critical section, process y will be in the waiting state. So px is in the critical section, process y will be suspended in the header of the queue. That header of the queue is called free. Now see what happens. Process x finishes working in the critical section. After process x finishes working in the critical section, it will then come out of the critical section and invoke the function called msignal. Now msignal is a function which is again belonging to the monitor, and we have seen that before entering the critical section, busy was set to true by px. Now px has come out of the critical section. It will then invoke the function msignal. Now what msignal will do is it will start executing on behalf of process x. Msignal is a public function of monitor that can be used by px or py. So process x has invoked the function msignal after coming out of the critical section. In the process monitor, the msignal function start executing on behalf of px. What this msignal will do is, as soon as px invokes the function msignal, it will set busy equal to false. Busy equal to false. So busy becomes equals to false. And after that, another instruction is executed, that is free.signal, means sending the wake up signal to the process y. Wake up means sending the process y from suspended state to ready state. Suspended state to ready state. So what happens? Process X finishes working in the critical section. It will invoke the function called mSignal. After mSignal function is executed, busy will become equal to false, and a wake up signal is sent to the process Y. Process Y was in the suspended state. When the wake up signal is sent to process Y by mSignal function, process Y will come from suspended state to the ready state. When it comes to the ready state, it will then invoke the function. It will come out of the mWait function. It will enter the critical section. So this way, this wait signal monitor program is acting as a semaphore, but it will not be very clear in this program to understand how the data or data structure is private to the monitor. I am only using this monitor program to imitate or to function as a semaphore. I am not using this monitor as a full-fledged monitor where monitor will perform exclusive and indirect access to data. So let us see another program which is full-fledgedly displaying the role of a monitor. Before understanding that monitor, what I am trying to explain you, let us take one example of multiple producers and multiple consumers sharing a common buffer. So here, this is the monitor that will allow multiple producers and multiple consumers to access a buffer. But please understand that this particular monitor, again, is not behaving as a semaphore. It is a full-fledged monitor that not only provides mutual exclusion, it also provides access to the data indirectly. So this buffer is an array. Size of the array is 1 to capacity. Capacity can be 10, 11 or whatever it might be. It can be 1 to n. Item can be data type. This data type can be of integer type or float type or whatever you want. In and out are 2 pointers. As we have seen in our earlier sessions in the buffer, if suppose we have 1 to 10 slots in the buffer, and suppose these are the field location of the buffer, so out will point to the next field location of the buffer and in will point to the next field location of the buffer. This you have seen already in the previous examples. Now may produce and may consumes are two conditions, means there are two queues. This is Q1. Header of the Q1 is called may produce. And there is another queue, Q2, and the header of this Q2 is called may consume. So two conditions means two header of the queues. One header of the queue is called may produce, one header of the queue is called may consume. Now what is that it is used for? See, whenever any producer wants to put the information in the buffer, if the buffer is filled, so what should happen? If the buffer is filled, the producer should wait in the header of the queue may produce. Similarly, when the consumer wants to access the buffer, if the buffer is empty, then the consumer should wait in the queue called may consume. This is why we are using may produce and may consume. So let us understand this. Here again, you understand that there are two functions in the monitor. Name of the monitor is B_B. This is the monitor name. This is the monitor name. Buffer is private to the monitor. In and out pointers are private to the monitor. May consume, may produce this condition private to the monitor. So these all are private to the monitor. They cannot be accessed by outside processes. They cannot be accessed by outside process. Input function is public. And there is a function called mTake. This function also is public. So input function will receive a parameter. It will receive a parameter. Means if any producer wants to put the information in the buffer, it will send the information through function called input. If the consumer wants to retrieve the information from the buffer, it should invoke the function called mtake. So mtake will return the value to the consumer. Remember, input will accept a parameter, mtake will return a value to the consumer. So just see here. If producer X or consumer Y has to use the buffer, they cannot use the buffer directly. If producer X want to input the information in the buffer, it should call the function input. If consumer Y wants to retrieve the information from the buffer, it should call the function mtake. This is how the producer consumer will be putting the information in the buffer. So PX is a outside process. It is not part of the monitor. And consumer Y is a outside process. Both are outside process. Nobody is belonging to the monitor. So CX is outside process. But both this outside process can use the public functions of the monitor. So as I said, in this particular program, monitor program, buffer is implemented using array. This will be hidden from the producer and consumer. They will not know that buffer is actually an array. In and out are pointers, may produce, may consumer, queues. Now, one more thing here, what you need to understand is that there is a variable by name count. So int count is initialized to 0. This I forgot to include in my program. So count is an integer, and this integer is initialized to 0. What is the purpose of count here? Count equal to 0 means the buffer does not have any information in it. So count equal to 0 means buffer is empty. Count equal to 0 means buffer is empty. If count is greater than 0, it means buffer has got some items in it. That's what you need to understand. So let us say capacity is assigned some 100. That means the buffer, which is actually an array, can store 100 items in it. So this B underscore B is the name of a monitor. It has got an array. Using an array, a buffer is implemented. That buffer is to be used by producer and consumer. Producer has to use the buffer to put the information in the buffer. Consumer wants the buffer to retrieve the information from the buffer. Producer need not be interested to know how the buffer is implemented. It should be only interested in putting the information in the buffer. Similarly, consumer need not be interested to know the structure of the buffer. The consumer can only put the information in the buffer. In and out are two pointers that are again private to the buffer. May produce, may consume are two conditions which are private to the buffer. Count is a integer variable, initialized to 0. So count equal to 0 means buffer is empty. Now let us say this is what is the initial structure of the monitor. Now a producer wants to retrieve the information from the buffer. Let us see what happens. So here please add one line, int count is equal to 0. Producer is outside process. If producer wants to put the information in the buffer, it will call the function input. And it will supply the information, say A is the information, supplied by the producer X to function called input. Input is a public function of monitor. Now what the monitor does is it will check whether count is equal to capacity. So count is 0 and capacity is, I said, 100. So 0 equal to 100 will be false. 0 equal to 100 will be false means the statement after then will not be executed. The control comes to the next line, and what happens? Whatever item has been sent by the producer to the monitor will be stored in the buffer. So buffer of in means store the information sent by the producer in the empty location of the buffer. Let us say this is the empty location pointed by in. So P item is having the information A. So this A will be stored in the location pointed by in. Then in is equal to in mod of capacity plus 1. So now this slot in the buffer is filled. So in will be pointed to the next location. So in will be now updated to the next location. So in will be pointing here now. Out will be pointing to the full location. So out will be pointing to full location. In will be pointing to the free location. Then count is equal to count plus 1. So count becomes equal to plus 1. Count is 1. Now let us not talk about the may consume dot signal. Let us come to consumer. If consumer wants to retrieve the information from the buffer, it will call mtake function. Now what mtake function will do? It will check whether count is equal to 0. Count is not equal to 0 because count is equal to 1. So this statement after then will not be executed. The control will go to the next line. Now what happens in the next line? Whatever item is there in the out location of the buffer is assigned to the variable C item. So out location has got a information A that will be assigned to the variable C item. Right? Next, out is incremented to out mod of capacity plus 1. So this information is removed from the buffer. So out is pointing to the next full location. So there is no full location. Out is pointing to the same location where in is pointing. If in is pointing and out is pointing to the same location, that also means the buffer is empty. That also means the buffer is empty. And this C item is returned back to the consumer. Out is incremented to next slot. Count is decremented by -1. It was 1. One item was removed by the consumer. So count becomes again equal to 1 minus 1, that is 0. Count becomes again equal to 0. So this is how the producer consumer will work. Now let us take a case where we'll understand why may produce dot signal is used or may consume dot signal is used. So after explaining this, I'll end my class today, and next class I will start with memory management. So let us see how this may produce may signal will work here. Let us take an example where the buffer is totally empty. It has got 100 slots, 1 to 100. In is pointing to the next free location, and out also points to the next free location. Means buffer is empty and count is equal to 0. Count is equal to 0. Now producer X doesn't start first. Let us say consumer Z starts first. It will invoke the function mtake. Now this function will be executed on behalf of consumer Z now. What monitor will do is it will check whether count is equal to 0. Yes, count is equal to 0 is true. Count equals to 0 is true means it will execute this function may consume dot wait. Means since the buffer is empty, the consumer should wait in the header of the queue called may consume. So may consume is the header of the queue, and this CZ will be suspended in the queue. This will be in the suspended state. Why it is suspended? Because count is equal to 0. That means buffer is empty. So consumer cannot execute. It's in the suspended state. After some time, producer X wants to produce the information. So it will invoke the function called input. It will supply the value B. The monitor will check whether count is equal to capacity. This is false because 0 equals to 100 is false. 0 equals to 100 is false. So what happens? This statement may produce dot wait will not be executed. The control goes to the next line, and this P item containing the value B will be assigned to the pointer in. So A will be assigned here. And in is incremented by in mod of capacity plus 1. So this pointer will now point to next location. That is here. Count is incremented by count plus 1. It was 0 here, now it becomes 1. So count becomes equal to 1. Then may consume dot signal is executed by the monitor. Now what happens is here? May consume dot signal means wake up signal is sent to the header of the queue. So wake up signal is sent to the header of the queue called may consume. When wake up signal is sent to the header of the queue called may consume, whichever process is suspended at the header of the queue will come from the suspended state to the ready state. And this program starts executing. So consumer will start running. Means here count equals to 0 will be false because it is 1 now. The control will come out of here. Consumer will be given the item B which was stored in the out location here. Out will be incremented to out mod of capacity plus 1 here. Again in and out are pointing to the same location, it means buffer has become empty. And may produce dot signal is executed by the mtech. Please remember that the may produced condition is header of the queue. May produce is header of the queue, but there is no process at the header of the queue. So may produce dot signal, if wake up signal is sent to the header of the queue which is empty, then it will not have any effect. It will not have any effect. Wake up signal sent to the header of the queue, and if the header of the queue is not having any process, so wake up signal will not have any kind of effect. If there is a process, producer process waiting here, and may produce dot signal is sent, then py will come from wake up state to the ready state to be executed. That is the meaning of it. So this is the monitor program here, and let us see how the producer function in consumer, how the producer program is written and how the consumer program is written. It will be very simple because producer need not have to maintain the buffer. Producer need not have to maintain the in pointer, out pointer. Producer need not check count is equal to 0 or not. Producer need not increment in pointer. Producer need not know whether the consumer is sleeping or not. Similarly, the code of consumer also will be very simple because consumer need not keep track of whether the buffer is empty or full. That is taken care by the monitor. Consumer need not increment the value of out by out mod of capacity plus 1. Consumer need not send a wake up signal to the producer. So the producer consumer code will be very simple here because all the things are done by the monitor. So if you see here, producer X here, the code is very simple for producer X. Producer X has a local variable called P item. So what the producer X will do, it will produce the item by invoking a function called produce. Produce is a function here. When you invoke when the producer invokes the function produce, a item will be produced. When item is produced, that item is returned back by the produce function that will be stored in the local variable of the producer called P item. Then what producer is doing? It is invoking the function of B underscore B. B underscore B is the name of the monitor. B underscore B is name of monitor. And within that monitor, what is there? There is a function called input. So it is something like in Java, when you declare a class is static, say static class A, then whatever methods are there in the class A, you can invoke the method by using the class name a dot method. So like in Java, if you declare a class as static, you can call the functions of that class by using the name of the class. We need not create the object. So you can say that b underscore b is name of the monitor, and within that monitor there is a function called input. So what the producer is doing here, producer is calling the function input by using the name of the monitor. B underscore b dot input means invoke the function input present in the monitor b underscore b. So what happens, whatever item is supplied by the producer through input, the monitor puts the information in the buffer. So the producer is using the buffer indirectly. The producer is using the buffer indirectly through the monitor. After the information is returned back to the after the producer puts the information in the buffer, the control comes back to the producer, and the producer can perform the other activity. Similarly, the consumer, if it wants any information in the buffer, it will invoke the function called mtech. Mtech is a function of monitor. Name of the monitor is b underscore b. Similarly, name of monitor is b underscore b, and within that monitor, the function name is mtech. So what happens? The consumer is indirectly accessing the buffer through the function called mtech, and the buffer is present in the monitor. So it will invoke the function mtech. If information is there in the buffer, that will be returned back to the monitor. The information will be returned back by the monitor to the consumer. The consumer can consume the information and perform the other activity. So what you see here is that the code of the producer and consumer becomes very simple, because all the information, all the manipulations of the buffer is done by the monitor. So nothing is to be taken care by the producer and consumer. So monitor will allow exclusive access to input function and mtech function. Only one producer can invoke input, only one consumer can invoke mtech. Two producers at the same time cannot invoke input function, two consumer cannot invoke mtech function at the same time. So since it allows only one producer to invoke the function input, since it allows only one consumer to invoke the function mtech, we are able to get the mutual exclusion implemented by the monitor. And by using this input and mtech, the monitor cannot, the producer cannot access the data directly, it is indirect. And consumer cannot access the buffer directly, it is indirect. So mutual exclusion also is supported, and indirect access to buffer also is supported. So that is the reason I told in the beginning that monitors will allow exclusive but indirect access to the resource. Semaphores will allow exclusive but direct access to the resource. Because semaphores will allow direct access to the resource, that's why the resource may be not protected. Since monitors allow indirect access to the resource remains protected. That's what is the meaning of monitors. So this will end up the third unit. I have only one more algorithm to discuss with you, that is dining philosopher's problem. I'll discuss that tomorrow. We'll start the fourth unit. This is memory management. My next class will be day after tomorrow, right? So shall we end the meeting? So finally, there are only 50 students available. If any doubts are there, you can see my video. I'll post the same video in my new LMS portal. You can go through my video once again. If after watching the video again you have any doubts, please let me know. I'll clear it in the next class. So thank you so much and have a good day. Thank you.